I could have assigned this to the individual one, and I realized I had not um, coordinated this with the scratch-off answer key, so I nixed it in class. But I wanted to go over it just so you knew how to do this. I suspect most of you don't need me to do this, but just in case, I want you to have thought about this. Anyway, the usual short-run cost framework is to map firm level, and I use small q to mean firm level, output to marginal cost, average cost, and of course average fixed cost, and price. This is dollars per unit of output, and these are units of output per some time period. Let's just say month, just because. Anyway, we have this critical upward sloping marginal cost function. There's a average variable cost function. And notice this intersection. I haven't drawn it the best there, but the intersection between the average variable cost and the marginal cost functions has to be at minimum average variable cost, because when marginal cost, the last unit produced, is below average variable cost, well, that's pulling average variable cost down. Average variable cost has to be falling. When marginal cost, the cost of producing the last unit, is above average variable cost, is pulling average variable cost up. The only way both of those things could be true is if they intersect at the bottom, at the minimum average variable cost. Now, by the same logic, the average total cost curve should also must also intersect the marginal cost curve at minimum average total cost. Now, one thing to notice, they ask us to draw the average fixed cost curve as well, and we'll do that, but realize that the vertical distance between average total cost and average variable cost is average fixed cost. So you don't generally add that average fixed cost curve, because there's plenty of curves going on here. You don't need one more to gunk things up. Plus, the average fixed cost curve always looks the same. But anyway, they ask us to do it, we'll do it. But these are the three that we normally will have as we analyze the short-run problem of the firm, and realize that the average fixed cost is embedded in this information. Notice I've drawn these curves so that initially the average total cost and the average variable costs are far apart. That's because early on average fixed costs, which is the difference between the two, is large. But as those two become, as quantity goes up, the difference between average total cost and average variable cost gets smaller and smaller. Realize we're just dividing some constant fixed cost by an ever increasing amount of quantity. I'm going to change the color just to remind ourselves that we don't usually have average fixed cost in there. I guess I should change the color of the pen is what I meant to do. So that average fixed cost looks like this. It's just a hyperbola ever getting ever closer to the origin. That's always what average fixed costs look like. And it doesn't matter where they intersect. It's just always a hyperbola. All right, so now we have an excise tax. And an excise tax is every 1 unit of output produced, there's a requirement to pay in this money to the government. And so that clearly is a variable cost. If we produce 0, we don't owe anything. If we produce 1 million, we owe 1 million times 0.39. So that's a variable cost. And what curves shift? Let's map that. Pretty much everything except for the average fixed cost, because marginal cost shifts up by 39 cents. Average variable cost shifts up by 39 cents. If I were really good, I'd draw that just so the new intersection was exactly the same distance above. This is the beauty of drawing by computer instead of by hand, but I'm drawing by hand here. And then finally, the average variable cost would shift up by that same, average total cost would shift up by that same amount. And I didn't do as well calibrating the distance between the new average total cost and the new average variable cost. So anyway, marginal cost, average variable cost, and average total cost shift, I sort of cut off that possibility, but it's D is the right answer.